Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals. And in this session we are going to discuss this definite integral where we have the limits 0 to pi by 3, and the integrand is mod of cosine 2x, right? So here our integrand is a mod function, and let us see how we can find out the value of this definite integral using two important concepts. The first one is the definition of modulus function, and then we'll make use of the sign convention of cosine function in the four quadrants, right? So let us start. So let us first make use of the substitution method, and let us first call this integral as I. So here we'll first take this 2x as t, right? So let us take t is equal to 2x, so that if we differentiate t with respect to x, we have dt over dx is equal to 2 times the derivative of x with respect to x, which is 1, that is equal to 2. So we can now write dx is equal to dt over 2. So here the limits of integration vary from 0 to pi by 3. So when x is equal to 0, then the value of t can be obtained from this expression. So we have t is equal to 2 times 0, that is equal to 0. And when x is equal to pi by 3, then the value of t is equal to 2 times pi by 3, that is 2 pi by 3, and 2 pi by 3 is equal to 120 degrees, right? So now let us rewrite this integral I in terms of t. So we can now write I is equal to t is equal to 0 to t is equal to 2 pi by 3, and here we have absolute value of cosine t, and for dx we can now write dt over 2. Now we can take half outside the integral, so we have half, and t varies from 0 to pi 2 pi by 3, and here we have absolute value of cosine t and dt. So now to move further, let us make use of the concept of mod function, and then we'll apply the concept of sign convention of cosine function in four quadrants. So here we have the four quadrants. Here we have 0, then we have pi by 2, here we have pi, here we have 3 pi by 2, and then we have 2 pi. So now we know that the cosine function is positive in the first quadrant and in the fourth quadrant, right? So here we have the first quadrant, here we have second, here we have third, and here we have fourth quadrant. So the cosine function is positive in the first and fourth quadrant, and it is negative in the second and third quadrant, right? Okay, so now let us make use of the definition of mod function. Now a mod of p is defined as positive p whenever p is greater than 0, and mod of p is 0 when p is equal to 0, and mod of p is equal to negative p when p is less than 0, right? So let us apply this definition to mod of cosine t. Now mod of cosine t can be defined using this definition. So we have positive cosine t whenever cosine t is greater than 0, and mod of cosine t is equal to 0 when cosine t is equal to 0, and mod of cosine t is equal to negative cosine t whenever cosine t is negative, right? So here mod cosine t is positive cosine t whenever cosine t is greater than 0, right? So cosine t is greater than 0 whenever cosine function has the value in the first and fourth quadrant. That is when t belongs to either the first quadrant or the fourth quadrant. So here we can also write when t belongs to either first quadrant or the fourth quadrant. And mod of cosine t is negative cosine t when cosine t is less than 0. It means when t belongs to the second quadrant or the third quadrant. So we can now write here t belongs to second quadrant or the third quadrant, and mod of cosine t is equal to 0 when cosine t is equal to 0. So it implies that t is an odd multiple of pi by 2, where n belongs to the set of integers. So now here the limits of integration are from 0 to 2 pi by 3, and 2 pi by 3 is 120 degrees. So it implies that this angle, that is 120 degrees, it falls in the second quadrant. So this angle is 2 pi by 3, right? So let us now split the limit of integration at this point, that is t is equal to pi by 2. So we have to now write I is equal to half, and then we'll split this integral into two parts. The first one is from 0 to pi by 2, right? Because when we go from 0 to pi by 2, we are in the first quadrant, and in the first quadrant, mod of cosine t is equal to positive cosine t. So here we write positive cosine t and dt, right? And then we go from t is equal to pi by 2 to t is equal to 2 pi by 3. So here we have pi by 2, here we have 2 pi by 3, and now we are in the second quadrant. And when we are in the second quadrant, then mod cosine t is equal to negative cosine t. So now we have to evaluate these two integrals. So now we know that the integral cosine t dt is equal to sine t, right? So now we can write here I is equal to half, and then here the integral of cosine t dt is sine t, and the limits of integration are from 0 to pi by 2. And here we can take this negative sign outside the integral. So here we have the negative sign, and then we have the integral cosine t dt, that is sine t, and limits of integration are from pi by 2 to 2 pi by 3. So now we can simply substitute the limits and we'll take the difference. So here we have now sine pi by 2. First we'll take t is equal to pi by 2, then we have t is equal to 0, and then here t is equal to 2 pi by 3, and then we have sine pi by 2, right? So now we can write half, and here sine pi by 2 is 1, sine 0 is 0, and sine 2 pi by 3, we can calculate sine 2 pi by 3 as sine pi minus pi by 3, right? So sine 2 pi by 3 can be written like this, sine pi minus pi by 3, and here we have sine pi by 3, because sine pi minus theta is equal to sine theta, and here theta is pi by 3, and sine 60 is equal to root 3 by 2. So here we have square root of 3 over 2. Sine pi by 2 is 1. So we have half, and then 1 minus 0 is 1. Then we have minus root 3 over 2. Then plus 1, minus and minus becomes positive. So we have half. 1 plus 1 is 2. 2 minus root 3 over 2. And multiplying these two quantities by half. Here we have 2 by 2. Here we have root 3 by 4. So here 2 and 2 get cancelled. So we have 1 minus root 3 over 4. That is 4 minus root 3 over 4. Right? So the value of this definite integral is given by 1 minus square root of 3 over 4, or 4 minus square root of 3 over 4. So this is how we can easily evaluate integrals of these type using the concept of mod function and the sign convention of trigonometric functions in 4 quadrants. Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals, and in this session we are going to discuss this definite integral that is from 0 to 5 pi by 16, and here the integrand is absolute value of sine 4x, right? So here we'll see how we can evaluate this definite integral using the concept of mod function, and then using the sign convention for trigonometric functions in 4 quadrants, and moreover we'll also make use of the method of substitution for integration, right? So let us first call this integral as I, right? So here our integrand is absolute value of sine 4x. So let us first make use of the method of substitution, and let us first take here t is equal to 4x. So if we take t is equal to 4x, then we can now write x is equal to t divided by 4. So now differentiating t with respect to x, we have dt over dx is equal to 4 times the derivative of x, which is equal to 1. So here we have 4, and we can now write dt over 4 is equal to dx, right? Okay, so now here the limits of integration vary from x is equal to 0 to x is equal to 5 pi over 16. So here the lower limit is 0 and the upper limit is 5 pi by 16. So let us now find out the values of t for x is equal to 0 and for x is equal to 5 pi by 16. So when x is equal to 0, t is equal to 4 times 0, that is equal to 0, and when x is 5 pi by 16, then t is 4 times 5 pi by 16. So this is 4 times 4 is 16, so this is 5 pi over 4, right? So now let us write this integral in terms of t. So now we can write I is equal to integral from 0 to 5 pi by 4, and here we have mod of sine 4x, that is absolute value of sine t, and for dx we can now write dt over 4. Now taking 1 over 4 outside the integral, we have 1 over 4, 0 to 5 pi over 4, and here we have mod sine t and dt, right? So now we have to evaluate this definite integral, and here we'll now make use of the concept of sign convention of trigonometric functions. That is, here we have the sine function, and we'll see the sign of sine function in the 4 quadrants. So now here we have the 4 quadrants This is first, this is second, this is third, and this is a fourth. Here we have 0, here we have pi by 2, this is pi, this is 3 pi by 2, and here we have 2 pi. And we know that the sine function is positive in the first and second quadrant, and it is negative in the third and fourth quadrant, right? So now let us make use of the definition of mod function. Now see, mod of p is defined as a positive p when p is greater than 0. A mod of p is equal to 0 when p is equal to 0, and mod of p is equal to negative p when p is less than 0. So let us apply this definition to mod sine t. So mod sine t can be defined as positive sine t, because now we can take p is equal to sine t. So mod of sine t is positive sine t whenever sine t is greater than 0, right? And sine t is greater than 0 for all values of t lying in the first and the second quadrant, because sine function is positive, that is greater than 0 in the first and second quadrant. So here we can write a t if t belongs to either the first quadrant or the second quadrant, right? And mod of sine t is equal to 0 when sine t is equal to 0, that is t is equal to n pi, where n belongs to the set of integers, right? And mod of sine t is equal to negative of sine t whenever sine t is less than 0. So sine t is less than 0, it implies that sine t is negative, and sine t is negative for all values of t lying in the third or fourth quadrant. So here we can write t belonging to either the third quadrant or the fourth quadrant, right? So now here we can write this integral I as 1 over 4, and here the lower limit is 0 and the upper limit is 5 pi by 4. And if we convert this angle into degrees, then we have 5 over 4 times that is 180 degrees, because pi radians is equal to 180 degrees. So here we have 45, and this is 225. So this angle, it falls in the third quadrant, right? So 5 pi by 4 or 225 degrees, it falls in the third quadrant, right? So now we have to split this integral as a sum of two integrals, right? So the first one is from 0 to pi, because from 0 to pi sine t is positive, and then from pi to 5 pi by 4, because this angle is 5 pi over 4. So now here we have to write 0 to pi. So the first integral is from 0 to pi, right? And then we have the second integral from pi to 5 pi by 4. So here this point, that is uh, t is equal to pi, is the point where we have to split the integral, right? Because from 0 to pi sine t is positive, and then from pi to 5 pi by 4 sine t is negative. So here we have mod of sine t dt, and here we have mod of sine t and dt. So now we can write 1 over 4, and we have 0 to pi, and mod sine t can now be written as positive sine t dt, right? Because here t varies from 0 to pi, that is we are in the first or the second quadrant. And here we have pi to 5 pi by 4. So from pi to 5 pi by 4, sine t is negative. So here we have minus sine t and dt. So now we have two simple integrals. So now we can write 1 over 4, and here the integral of sine t is negative of cosine t, and we have 0 to pi, and here we can take this negative sign outside the integral, and the integral of sine t is minus cosine t, and we have the limits pi to 5 pi by 4, right? So now we can simply substitute the limits, and we'll take the difference. So now we can write this integral I as 1 over 4, and here we can take this negative sign outside, and then we have cos pi, and then we have cos 0, and similarly here we have this negative sign outside, then we can multiply this negative with this negative, so we have here positive, and then we have cos 5 pi by 4, and then we have minus cos pi, right? So now we can easily simplify this expression. So we have 1 over 4, and here we have cosine pi is equal to minus 1, cosine 0 is equal to plus 1. So we have minus 1, then we have here 1, and then we have cos 5 pi by 4. Now we can calculate cos 5 pi by 4 using some trigonometry here, and we can now write 5 pi by 4 as pi plus pi by 4. So this is of this form, pi plus theta, where theta is pi over 4. So cosine pi plus theta is negative cosine theta. So here we have negative cosine pi by 4, and cosine pi by 4 is equal to 1 over square root of 2. So here we have 1 over square root of 2. So now here we can write minus 1 over root 2, and here we have minus and minus 1. So now we can write here 1 over 4. Here we have minus 2, and we can now write here positive, and then we have here minus 1 over root 2, minus and minus, it becomes positive, and we can now write 1 over 4, and here we have plus 2, then we have minus 1 over root 2 plus 1, right? So this is 1 over 4, and here 2 plus 1 is 3, and minus 1 over root 2. So now we can write here this expression as 1 over 4. We have 3 root 2 minus 1 over square root of 2. So now we can write the value of I as 3 root 2 minus 1 over 4 times square root of 2, right? So viewers, the value of this definite integral is given by this expression.